All right, guys, we're done with the oxidation of alkanes in the presence of cold acidified KMnO4, and it was dilute in that case. And the product that we got is diol. All right. So what happened if you put the alkene in harsher conditions, like hot, concentrated, acidified KMnO4? We're going to apply heat and we're going to use concentrated KMnO4. According to the products that we're gonna get in our case, carbon dioxide in water or carboxylic acid or ketone. So all of these products depend on the structure of alkene. The structure of alkene. How can we apply this word? So let's start with rule number 1. Okay, rule number 1 says if you have a carbon and carbon, you have double bond in here. So let's take the case number 1. When the carbon on the double bond is bonded to 2 hydrogen atoms, what will be the product in this case? Put in your mind, the breaking of the bond will be in here. Okay, the double bond will be broken. So the product that will be produced directly is, like CH2, the whole compound will change to carbon dioxide in water, H2O. And we can understand that in terms of, let's say, the mechanism, or let's say the intermediate in this case. So we just noticed that we have carbon, all right, that has a double bond and it's bonded to 2 hydrogens. We're talking about the oxidation process, which means that we're adding oxygen atoms. So the oxygen atoms will be bonded instead of hydrogen and instead of this hydrogen. We're gonna get carbon dioxide, okay, and you just notice that these hydrogens are bonded to oxygen to form water molecule, okay. But just like a small hint to you, before changing this compound immediately to carbon dioxide, it will change to intermediate for a short period of time, and this intermediate is methanoic acid, which means C double bond OH, and here we have H, and then it will immediately change to carbon dioxide. One of the most famous observations about these reactions, once you make the oxidation, you will notice the formation of fizzing or bubbles, and the bubbles belong to the carbon dioxide gas. And by the way, this test, oxidation of alkene, can tell us a beautiful information, or let's say a beautiful hint, that the double bond is between carbon 1 and carbon 2. So we can say like you have carbon 1 and 2, and that's why you will notice the presence, or let's say the formation of carbon dioxide. We can test the carbon dioxide gas by lime water, and the lime water is calcium hydroxide, all right, that will be changed to calcium carbonate, okay, which is insoluble, and the observation will be turning the lime water milky due to the formation of calcium carbonate. Okay, let's go to the second case, and the second case says if the double bond carbon consists of 1 hydrogen and 1 alkyl group, the alkyl group could be methyl, ethyl, like any hydrocarbon. Okay, so what will happen as a result of that? Put in your mind, we're gonna break this bond, okay? So this bond will be broken, as we can see, like C, we have C, and this double bond will have oxygen, and here we have hydrogen. Okay, this is the first step of oxidation. So once you get this compound, it's called aldehyde, and yeah, so you're adding a concentrated acidified KMnO4, and this is in the presence of heat, you will get aldehyde. The aldehyde doesn't long for a long period of time. It will change immediately to carboxylic acid, and the carboxylic acid, it looks like a little bit like aldehyde, but the only difference is the presence of the OH group. So What is the aldehyde group? The aldehyde represents the presence of double bond OH, okay, and the carbon is bonded in the other area with R group, okay? So the aldehyde will change immediately to carboxylic acid. The carboxylic acid looks like R group that is bonded to C double bond O and OH. And put in your mind, the carboxylic acid reacts with metal carbonates because metal carbonates are basic and carboxylic acids are weak acids. Okay, so let's go to the last one, or let's say the third part of our story, which is when you have a double bond, okay, that is bonded to two R groups. And again, the R groups represent the methyl, ethyl, hydrocarbons. What will happen here? We're gonna go to break the bond in here. Okay, so as a result of breaking the bond, we're gonna go to something looks like C double bond. You have R groups, and we put oxygen in here. So once you have a C double bond R, which is called carbonyl group that is between two R groups, the whole compound in this case is called ketone. This is ketone. The ketone is two R groups, okay, and they have carbonyl in between. And now let's take real examples about our lesson. All right. Let's start with this one, like CH2, double bond, CH3. Okay, so as we can see, we're gonna apply acidified KMnO4 and heat. So we're talking about harsh conditions, and this is oxidation process. So once you break this bond in here, okay, you will get two products. Okay, you'll get two products. Look at this one here. You have CH2. Once you find, according to the rules, this material will change immediately to carbon dioxide and water. Okay, what about this? You just notice that this carbon is bonded to methyl, okay, and hydrogen. So according to the rule that we remember, this compound will change to carboxylic acid. I just want to use another color that is brighter a little bit. Yeah, this carbon is bonded to hydrogen and carbon. Okay, I mean, it looks like this, like hydrogen, and here you have CH3. So once you have this double bond, it will change immediately to carboxylic acid. So you'll notice that the hydrogen will change to OH and CH3. So this is carboxylic acid. This is carbon dioxide in water. Okay, so what you can say, or let's say what you conclude in this, what if I want to use this simple, like, oh, in this case, if I want to describe my process. So what to do? I just want to rewrite this again in here, like CH2, double bond, CH3, plus you want to add oxygen in here, and leads to give what? We can add this simple instead of adding KMnO4 and this stuff. So the product will be, as we can see, we have one product in here. We're gonna get CO2 plus H2O plus C double bond OH and CH3. And now let's count the number of oxygens that we have here. Here we have two oxygen from carbon dioxide, and here we have one oxygen from water, and here we have two oxygens in this one here, which means in this case, we have 5 oxygens. Okay, I just want to recount them again. We have 1, 2, 3, 4, 5. Yes, we have 5 oxygens. So we can multiply this by 5 easily. If you want to count the number of hydrogens, you just remember that these are the same. Here we have 3 hydrogen, 4, 5, 6. And here we have 3, 5, 6. Then we have same number of atoms in both sides. H3, that is bonded to 2. And here we have double bond C, H, C, H2, CH3. In this case, you should understand how to translate this to a formula that you can understand. So as we can see here, C that is bonded to two methyl groups, it looks like this, CH3 and CH3. You have a double bond, CH, it means this C is bonded to H and it's bonded to C2H3. Like these are the same. So you could have, say, like you have hydrogen and here you have CH2CH3. Okay, we're gonna add acidified, concentrated KMnO4, all right, and presence of heat. So what to do in this case? We're gonna break this bond here, and this product will be C double bond O, CH3, CH3, and this is ketone, by the way. What about this compound? You just notice that this compound, or let's say this carbon is bonded to hydrogen and this, which means it will change to carboxylic acid. So you will just do it like this. We have double bond, okay, and you have CH2 no change, and the H is changed to carboxylic acid in this case. So this is the beautiful thing that you, okay, so these are the products that you have. If you want to write these in terms of the, like this one, you can say like how many oxygens are gained in here. You have 1, 2, 3. Then you have to say like you have 3 oxygens are gained in this case. Let's take another advanced one that you have this one here. How can I deal with such compound? And we added KMnO4 that is acidified and presence of heat. So this is a harsh condition, the acidified with concentrated. According to what we see, we're gonna have the break in this bond in here, okay? And then it will look like, once you just look at this compound, you can say we have carbons in here, and these carbons, each carbon in the double bond makes 3 bonds, which means we have hydrogen and we have another hydrogen. Okay, what does this mean? It means we're gonna go and change these to carboxylic acids. So the bond breaking is in here, okay? And then it will look like this. It will look like this. You're gonna have this one. You have O. We break the bond and just put O's in here. And we told you that we have hydrogens. These will change to OH. Okay, but you notice that you open the change, you break the bond in here. So you can say, I can write it as a straight chain easily. So you can count the number of carbons, so that makes it easier to you. You can say like this is 1, 2, 3, 4, 5. Okay, so I want to translate that. Why did I put these numbers? So if I draw the compound, it can put the double bond. So I will draw a series, or let's say a chain that is consists of 5 carbons. We have 1, 2, 3, 4, 5. At the 5 and the first one, we have the double bonds. You have OH. Here we have double bond OH. So according to what we see, we have carbon 1, 2, 3, 4, 5. So number 5 has a double bond OH. Number 1 has double bond OH. So this is the same as this. Let's take another one. What if you have like a C double bond? We're gonna go with the same one, but in this case we have methyl group. This is methyl. As we can see, the breaking will be in this area. You will get something like this. I just will put the reagents before that. KMnO4. And you're gonna add heat. Okay, you will draw the same thing here, but you will put the double bond in here. Okay, you just notice that we have methyl group in this case. This is a methyl, like here, and this area has hydrogen. Okay, and will change to carboxylic acid. So this is the compound. If you want to draw it in terms of, let's say, like a chain, you can start counting the number 1, 2, 3, 4, 5, 6. So you can go and draw 6 carbons. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, right? Okay, so carbon number 2 has a double bond, which is in here. And let's count 1, 2, 3, 4, 5, 6. You can count from where you like, from the left or the right, doesn't matter. And on the terminal one, you have double bond and you have OH. So this is the same as this. Let's take another one. Okay. Let's take something like this. Yeah. Yes. And we just added KMnO4. Okay. That is acidified. And we apply here. So once you find a double bond, you have to break it. Okay. How can I understand this bond? It seems that you have carbons on each edge. And once you have a double bond, it means that you have CH2 in here. Okay. You remember, this is skeletal formula. So how can I apply this? Where is the breaking? It will be in here. So we're going to apply a breaking of the double bond in here, and you will have O. And you just remember, once you break the CH2, you'll be given carbon dioxide and water molecule. Okay, so this is the story that you have. According to the number of oxygens that are gained, you have 1 in here, 1 in here, and 2 in here. So the total number is 4 oxygens. So if I want to describe it in terms of this, you can say you have 4 oxygens.